Okay, so last time we went through what you need basically to graph a quadratic function. I know it's kind of silly because since the exams in this class are open book, open notes, I don't think I can really ask you to graph a quadratic function. What I can do though is ask you, for instance, what's the vertex, the axis of symmetry, things like that. And we have formulas for that. You know, we saw last time that if you have a quadratic function, like so, remember the domain is always all real numbers. That's what this notation means. The domain is everything, okay? The vertex is this. And really, I'm just trying to illustrate how you get the vertex. You know, for instance, if you have negative b over 2 times a, once you calculate that, you get the y coordinate by plugging it into the function. So really, negative b over 2a is the big, important calculation, so to say. And not only that, the axis of symmetry, it's the vertical line through the vertex, so it has this equation. Remember, the axis of symmetry, that's the line where if you imagine taking the graph and folding it folding it about that line, both halves of the graph would match up and overlap exactly. I mean, that's the idea. I know it's a little bit of visualization, but that's what it is by definition. For the y-intercept, okay, that's just f of 0. I mean, if you have your quadratic function like this, it's just going to be the constant term c. Also because these things with x are going to go away. These terms, with x's in them, they're going to vanish. They're going to be gone. So just want to make sure that you see that. Also, I did show last time, you can get the range from the graph. You know, you really should be able to do that. But also, okay, you can get the range without even graphing it. Remember, wait, let me just say this also. To get the x-intercepts, you solve this equation. And again, what you'll generally have to do is the quadratic formula. I mean, you could factor it. You could. Factoring gives you a lot of other techniques. I mean, if we had a polynomial of degree higher than 3, higher than 2, although for degree 3 and degree 4, there are formulas. The one for degree 4 is really huge. I don't have enough room on the slide to write it. But basically, once you go beyond degree 5, there are no formulas for solving this equation. So the technique of factoring is still very important. But for quadratic equations, we really just have the quadratic formula. And what I was saying here with the range, remember, if your a is positive, right, the graph's going to open upward like this, almost like a smiley face, if that makes sense. Okay? I mean, usually in the graph, we don't draw these arrows, but it's understood that the graph keeps on going up. The vertex is at the very bottom. So the range will be from the vertex, from the y-coordinate of it, up to infinity. So in other words, the range will be something like this. Let's see if I can draw it. That's the y-coordinate of the vertex. Boy, bear with me. It's going to look something like this. Okay? And again, this is if a is positive. That's if a is positive. And if a is negative, essentially you're going to invert that. That is, if a happens to be negative, right, then the graph does something like this. So now the graph's going to do something like this. And so the graph does something like this, and the vertex is at the very top. So the range will be minus infinity, comma, to the y-coordinate of the vertex. So basically, you can get the range without even graphing it. I mean, the domain's always going to be the same, so the domain's easy. The range you can get without graphing it. You just have to know if A is positive or if A is negative, and the vertex. That's what I'm trying to show you here. Well, let's do an example, and then you'll get the chance of doing some examples today as well. So here's this example. Now, remember, you always want to get, as I have here, your A, B, and C. You always want to get that. And remember, A is the leading coefficient, B is the coefficient of X, and C is the constant term. I mean, A has to be non-zero, which is good because we're dividing by A. So if A was 0, then we're back in, what section was it? I guess earlier of chapter 2, because then we just have a line. Oh, sorry. All right. So, okay, so we have to get this first. Remember, I'm using the Vertex Formula. What's nice is you don't have to memorize this because it's in the notes. I did email an outline of the notes, which has this slide, although it doesn't have this stuff on it. But I figured that's okay. So from here, right, we have A is 1, B is -6, C is 5. And so from here, we get X is we get -B over 2 times A. That's going to be -6 over 2 times 1, which is just 6 over 2, which is 3. Okay, that's good. So that tells you right away that the axis of symmetry is 3, which I have down here, I know. And not only that, to get the y coordinate of the vertex, you have to do f of that. Right? Every point on the graph is of the form x comma f of x. The y coordinate is always a function value, the function value of the x coordinate. So f of this, we just calculated f of 3, which is this. As you can see, I'm just plugging it into the function. That's all I'm doing. Okay? We get 3 squared, which is 9, minus 6 times 3, which is 18 plus 5. And of course, you're going to get -4. So the vertex is this point, as we can see. The axis of symmetry is this. And the y-intercept, remember, you could do f of 0. I didn't write the calculation, but I really hope you can see it. It's just the constant term c, which is the same as f of 0. And right away, we can determine the range of this thing. In fact, for fun, I'm going to do that. So for the range, okay, for the range, since A is positive, right? A is positive, okay? So we know the graph's going to open upward like this. Even though we're not graphing it, I mean, yeah, we're not graphing it by hand. We know that the graph has to open upward. I mean, you could graph it in Desmos to double check, but we know it has to open upward. So because of that, we know the vertex is at the bottom, and the range has to go from -4 all the way to infinity. The graph is going up, 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 going up, getting bigger and bigger, up to infinity. The vertex is at the very bottom. So we know what the range has to be. And that's cool. What are we missing here? Well, we're missing x-intercepts. Well, that's what this is for, as you can see, quadratic formula. I wrote A, B, and C again. The x-intercepts, right? We have the quadratic formula. So I'm just plugging it into the formula. That's all I'm doing. Notice that we get -6, which is 6. You have 6 squared minus 4 times 1 times 5. Well, that's 36 minus 20, which we know is 16. Dividing by 2. 16 is the perfect square, which is nice. Square root of 16 is 4, which is cool. And so we get 2 solutions here. One where you have addition. The other one is by subtraction, as you can see. So we have 6 plus 4 over 2. 10 over 2 is 5. 6 minus 4 over 2. 6 minus 4 over 2, which is 1. Let me say this also. What I've seen people do in the past is where you have like B, A, and C, I've seen students put X in there as well as the actual numbers. The only thing that goes in here are the numbers, okay? I've seen people make the mistake where they would put they would have minus 6 times X, where they have minus 6. So here they would have minus 6x squared minus 4 times x squared plus 5. What I'm saying is don't do that. You just want the numbers. Now that we know the x-intercepts, we know at least what the graph's going to look like. Namely, from here, we have the vertex down here, as you can see. The axis of symmetry, let me just sketch that. I mean, that's pretty easy to do. Generally, I have not asked people to sketch the axis of symmetry anyway, but I'm just going to draw it for fun. The y-intercept, that's up here, right? Y-intercept, as you can see. The x-intercept, remember, that's where the graph crosses the x-axis. So it's going to look like this. That's one of them. That's the other one, as you can see. And the range is from minus 4 to infinity. Again, you could get that by what I was trying to show you last time. You can imagine moving the graph towards the y-axis, projecting it on there, you'll get minus 4 to infinity. I mean, it has to start here and go up. That's the first example. Okay, let me just stop the recording.